What's up, math fans? Today I want to do a similar video to one that I've already done. I want to solve a system of 3 equations using elimination. The last one I used substitution, but they kind of go hand in hand because you use a little bit of substitution and a little bit of elimination in both. When I say elimination, there's a procedure that you learned in Algebra 1 called elimination. When you first learned it, you learned it with just 2 equations and 2 variables, and your goal was to eliminate one of the variables so you could solve for the other one. So that's the same idea here. So you want to kind of start to eliminate variables and simplify it until you can get your variables alone. So when you say solve, that means I need to get x, y, and z all alone. What that means is, well, this represents a line. Here's another line and a third line. So you kind of got 3 lines in 3D. You're used to 2D, right? X and Y. Now you got 3D, and you want to find where those 3 lines intersect. So the intersection is going to be x, y, and z. That's somewhere in the 3-dimensional plane. So this kind of stuff is a little more interesting and a little more realistic because we live in 3 dimensions. People ask me, oh, is there an easier way to do this? Because it is a long procedure. You do need patience and discipline. You might mess up and have to start over, and that's okay. There's different paths to doing this. I don't want to say it's easier, but there's a way where you take all the coefficients, including the solution, and put it into a matrix. And it's not a matrix video, so I might let you look up matrix on your own, but solving matrices are kind of fun too, so feel free. And yes, the movie with all the numbers falling down, a bunch of numbers, that's basically a matrix. So let's see here. My way is I'm going to use elimination. I'm going to pick 2 at a time, and I'm going to use the rules that I learned for algebra. Basic rules for algebra is you can do whatever you want to an equation as long as you maintain the equality or the balance. Meaning, I can multiply whatever I want as long as I do it to all the terms. Same thing with division. I can divide as long as I do it to all the terms. You can add as long as you do it to both sides of the equation. You can subtract as long as you do it to both sides of the equation. You can also add 2 equations together. Any 2, the first 2 or the second 2 or the top and the bottom. So I'm going to inspect this thing and figure out which 2 I want to work with. And it looks like I have a negative y and a positive y, so I want to work with the first and the last. So I'm going to rewrite that. X minus y minus 2z equals negative 6, and that. Okay? Now the reason I did that is not only my variables are lined up, but these are already inverses. So all I have to do is what's called elimination, or some people call it addition, because I'm going to put a giant plus sign here and add straight down. And what happens? Goodbye. Inverses cancel out. And I've streamlined this thing by eliminating the y's. I have negative 3x minus 3z equals, looks like 6. All right, check my work. I might mess up and have to spend more time fixing it. So I've slimmed it down to just an x and a z. This one also looks kind of slim because it's just an x and a y, but that's not going to help. I need another one with just an x and a z. So I'm going to pick 2 more now. Let's see. So we'll put this on the side for a second. And I'm gonna pick the middle guy because we didn't get to use him yet. So I got my 3x plus 2y equals negative 25. And actually what I'm gonna do is kind of slide over that negative 25, and you'll see why in a second, or you already know. And I want to line it up with something. So could I use the first one or the last one? It's up to me, right? And if I don't like it, I can change it. But let's see. I'm gonna want the y's to cancel out again. So let me go with the one where there's a negative y. You could go with the one where there's a positive y too and still make it work, but I'm going to go with the one where there's already a negative y. So x minus y minus 2z equals negative 6. Nothing eliminates, but remember what I said. You can multiply whatever you want. So now I'm looking for the least common multiple of 2 and 1. Which is easy, that's 2. I just need a 2 here so that I can cross them out. So I do what algebra lets me do, multiply by 2 and distribute so that all terms maintaining the balance or the equality. So what happens to the first equation? Nothing. Write it again. 3x plus 2y blank space equals negative 25. And here, this becomes 2x minus 2y minus 4z, right? 2 times 2 is 4, equals negative, looks like 12. And now I can use elimination again, also known as addition. What happens? Goodbye. You'll notice why I put that space there now. So 3x plus 2x is 5x. Nothing plus negative 4z is negative 4z. And that equals, looks like negative 37. That's a weird number. I hope it works out for me. So here I have an equation with an x and a z. Here I have an equation with an x and a z. They line up pretty nicely. Negative 3x minus 3z equals 6. And so I'm taking this and I'm putting it here. And then I'm taking this, and I'm going to put it up there also. So that's 5x minus 4z equals negative 37. And now you have a choice. Again, you need to find the least common multiple of whatever you want. You want to eliminate the x's or the z's? I'm going to go with the x's. It really doesn't matter. So I'm going to multiply this. Oh, be careful. That's a negative 3, right? Negative 3. So I'm going to multiply the top equation by 5, and I'm going to multiply the bottom equation by 3. Why would I do that? Because the least common multiple of 3 and 5 is 15. How do I create a 15? Multiply by 5 up here. How do I create a 15 here? Multiply by 3 down here. So again, let's see what happens. I'm going to have to write small so you can see this. This is going to become negative 15x, right? Negative 15x minus 15z equals 30. And again, please check my math. The bottom one becomes positive 15x minus, what is this, 12? 12z equals, I have no idea, so don't look at this part. 37 times 3 is 21, 9, 11. Negative 111, I hope. And again, I'm using addition here, so that can cancel. I can get negative 27z equals negative 111 plus 30, right? So that should give me 81. 81, negative 81, negative 81, okay? Again, keep checking, get a calculator. Now I'm going to divide by the coefficient, which is negative 27, and I finally got z alone. 81 divided by 27, I sure hope is 3. Again, if you don't believe me, 27 times 3 is 81, hooray! So that's a negative 3? No, that's a positive 3. Negative divided by negative is positive. And I am done with the hard part, the matching up, the eliminating, the least common multiple, all that's done. I got z alone, now I work backwards. I go to one of these two original equations, and I plug in z to find x. I'm actually going to go back to the original, no I can't, so I'm gonna pick one of these two. I like the second one, it really doesn't matter. So again, hopefully you can see I'm going to write small. 5x minus 4 times 3 equals negative 37. So 5x minus 12 equals negative 37. 5x, if I add 12 to both sides, 5x equals, I don't know, negative 25, okay? Because I added 12 to both sides, and negative 37 plus 12 is negative 25. Divide by 5, divide by 5, x equals negative 5. I got z, I got x, I'm almost done. I'm going to go here now to the original, which is 3x plus 2y equals negative 25, which is 3 times negative 5, right? I'm using x as negative 5, plus 2y equals negative 25. That's a negative 15 plus 2y equals negative 25. Add 15 this time to both sides. So 2y equals negative 10. And divide by 2 on both sides. So y equals negative 5. Okay, I got my y, I got my x, I got my z. So my solution is x, y, z. That is the coordinates of where the 3 lines would intersect. All right, so just be patient. You can do this. Thanks for watching. See ya.